Apollo 16 never took a picture of the Earth. They waited till the last possible minute, so that way you couldn't compare pictures. It was perfect. Then on the way back, Apollo 17 takes a picture that shows two things. Even though it was an American space program, it showed two things that were relevant. One was Africa, part of Africa, and the other part was the only continent that showed in its entirety was Antarctica.
Hey guys, welcome back to another video. Today I'm going to be taking a look at another flat earther, but this is not just any flat earther. It's Mark Sargent, God of the Morons. So, flat earthers somehow held a conference in Canada where Mark presented 5 proofs of the flat earth. Today, I'm going to debunk these points. Before I begin, remember to like the video and subscribe.
Is what I read on camera. 1. Long-distance photography. The mainstream science formula for the curvature of the Earth is 8 inches per mile squared. An easy comparison would be the falling rate of 32 feet per second. So 8 inches per mile per mile. 2 miles is 2 times 2 equals 4 times 8 inches or 32. 3 miles is 3 times 3 equals 9 times 8 or 72. And so on. At 50 miles, the curvature is 50 times 50 times 8, coming in at over 1,600 feet of curvature. And yet, with HD cameras, we can pull boats back into frame that are well beyond visual range.
Yes, we can see a boat about 50 miles away with an HD camera. That just means a boat we can no longer see with our eyes is now viewable through a camera. But it depends on the height at which you are using the camera, because it would not be possible at sea level.
Not only does the new technology clearly show that it's not a mirage, but the same objects can be viewed in infrared and can be targeted ship to ship by beam radar. Can science explain this? They had no answer.
Yes, science can explain this. Infrared detectors, or cameras, simply pick up infrared radiation, which is produced by boats. So, that is not a valid point. Secondly, radars that are used to detect objects over the horizon use a transmitting antenna that produces a powerful signal. This signal then refracts off the ionosphere. The echo signal then follows the same path to the receiving antenna. No one said the path from point A to B had to be straight.
Number 2, vacuum versus gravity. The force of a vacuum is measured in units of torr, T-O-R-R. Even a low-level vacuum can overcome gravity here on the surface. In building molecule-free chambers for the manufacturing of electronics, a series of massive pumps are needed to create a 99% vacuum. That's -9 torr. And for the remaining 1%, horsepower isn't enough. It can only be achieved by a chemical leaching process. That being said, how is the -10 torr vacuum force of space not ripping off the atmosphere of this world?
To put it simply, the answer is gravity. Gravity pulls the atmosphere, compresses it, and creates pressure. But a common misconception that flat earthers make is that the vacuum of space sucks things into it. This is not true. Vacuums do not exert any force. Instead, what happens is that the air pressure pushes the air into filling the vacuum. On Earth, our air pressure is a gradient, and near the upper limits, the air pressure is almost nothing, and therefore there is no force to push the atmosphere to fill the vacuum of space. And, in conjunction with gravity, the result is an atmosphere that remains clinged to our round planet. It's hard to wrap one's head around this because we see vacuums suck dust every single day, but at this stage, Mark should have.
What is gravity? And remember that there are gases that already defy it, like helium, hydrogen, and fluorocarbons. Isn't it more logical to suggest that the atmosphere is being contained in an enclosed, pressurized system? They had no answer.
Well, gravity is a force that pulls all matter together. Also, helium is lighter than air, and as long as it is lighter than the air it has displaced, it will float. Not that hard to understand, Mark. Also, I want to speak with these people who don't have an answer to all your questions.
Number 3, eclipse shadow. Mainstream science tells us that the moon is over 2,000 miles wide, and yet during the 2017 American eclipse, no offense, the moon's shadow was only 70 miles wide, a reduction of over 97%. This is what the equivalent of having a 6-foot man walking in front of a wall where his shadow is smaller than an action figure at only 2 inches. Where do we see this in our everyday lives? We've seen a shadow's actual size and some much larger. Where can we see small shadows? The Flat Earth community says that the moon is less than 50 miles wide, much closer and the same size as the sun. Isn't this explanation also possible? They had no answer.
Okay, the reason the size of the moon's shadow is so small is easy to understand, unless you're Mark. During a solar eclipse, the moon comes between the Earth and the sun. Due to the geometry of eclipses, the moon's shadow narrows, so the region the eclipse is visible is very small.
Number 4, moon temperature. Science has yet to address this relatively new discovery that the moon generates a cold light. We all know that in the daytime it is 90 degrees in the sunlight, 80 degrees in the shade, depending on the conditions. I know I'm not going to do the Celsius conversion up here, sorry. However, at night, especially when the moon is high in the sky, we see the opposite. While it might be 50 degrees in the moonlight, it's warmer at 60 degrees in the moon's shade, sometimes showing temperature shifts of over 13 degrees Fahrenheit. In addition, under controlled experiment conditions, magnified moonlight is even colder still, again, the opposite of sunlight. We can generate this with technology today using a cold laser. The question is, why is the moon giving off a cold laser light? They had no answer.
The moon's light does not cause an object to get cooler. Instead, the object in the shade gets warmer as less of the heat is radiated into the air, therefore becoming warmer than an object that is exposed. Actually, moonlight has nothing to do with this. It's radiative cooling. Surfaces with an unobstructed night sky will lose more heat than surfaces that are obstructed, even if the moon is not present.
Last but not least, the Van Allen belts. A simple yes or no question. Are the Van Allen radiation belts deadly? If yes, then how did Apollo 11 through 17 make round trips through these belts with only aluminum and plastic as shielding? No one died, no one got radiation poisoning, nobody even got cancer. I think there's still like 5 left. Radiation is only stopped by 2 metals, lead and gold. Both are very heavy and cannot be used in aerospace because of their weight. If the answer is no, the belts are not deadly, then explain the video currently on the NASA.gov website called Orion Trial by Fire, in which NASA clearly states the belts are so dangerous they will not be testing manned capsules because they are unable to solve the radiation problem. Keep in mind, this is not an old video. It was created at the end of 2014. The scientist viewed my recording and folded like a card table. This piece was never aired.
Yes, they are deadly. Also, Mark mentioned plastic, but not the specific type of plastic. Polyethylene was the plastic used on the Apollo missions, which is good at dispersing radiation. Also, there are other good metals, such as aluminum, that can block certain types of radiation.
All that being said, my name is Mark Sargent, and I'm a flat earther.
Well guys, that about wraps up the video. Once again, remember to like and subscribe, and check out my other videos. Thanks for watching.